Welcome back to Brain Time, the show where we take your questions and have them answered by real professionals. My name is Kincaid Fiscus, and today's theme is wireless energy. Now, our first question is, how does wireless energy work? Well, let's see what Professor Stephen Alledge has to say on the topic.
Hello, Kincaid. This is your father's uncle, and I'm here to tell you something about wireless power transfer, since you asked the question. So this is my lab at the University of Maryland, and I'm a physics professor here, and I'm going to tell you a little bit about wireless power transfer since you asked. And it's a really cool topic. So we're looking for ways to transfer energy between two places without using wires, right? So most people, when they want to make something work, they plug this thing into the wall and somehow magically electrical energy comes out of the wall and it powers up your computers or your cell phone or your electric vehicle or whatever. So we're interested in finding a way to get rid of the wires and to use antennas, like this, where you can send energy through the air, just like Tesla was trying to do back in the day. So I'll tell you a little bit about our wireless power transfer techniques. We have two of them, and the basic idea is that we work inside like an enclosed region, right? So like this room, for example, or this box here. This is a big empty box that has metallic walls on it, and we use this as a scattering environment. So we send waves inside this system using antennas similar to the one I showed you here. We send the energy into this box, and it moves around inside the box in many different directions, many different ways. And we design the waves that we put in there in such a way that they come together at one particular point at one particular time. And they use this thing called superposition, that waves of the same frequency but coming from different directions can all come together, and their amplitudes can add and add and add and add, and at some point they can be very intense when they add up all together. That's called constructive interference. So we design waves to go into this big empty box here to come together in one place at one time with very intense, very high amplitudes. And that way we can design a device that would sit there and just accept that energy and basically transfer it without any wires in the system. But we have to use waves. We have to have waves kind of reverberating around inside this system. All right. The first wireless power transfer technique we use is called time reversal technique. And in this case, we have an object that's somewhere inside this box. So it could be anywhere inside. This is a big empty aluminum box here. And so it sends out a very short pulse of radiation, and that sends radiation in all different directions inside the box. And then typically we will just collect that radiation by putting an antenna at one point, on the wall of this box, and we'll collect that signal using various kinds of instruments like this one here. And we'll collect that and record it. And then after all the waves die down from that initial burst of signals, we'll then take the signal that we recorded in this instrument and actually play it backwards in time and put it back to the same place where we collected it and send it into this big empty box. And then those waves then follow the same trajectories. They still bounce around, but in the time reverse direction. And at one point, because of the superposition principle that I mentioned, all of those waves will come back and superimpose on the object that we're trying to feed energy to. And that works very well. We have a patent on that. This is the US patent that is using the fact that you can have wireless power transfer with this time reversed electromagnetic wave propagation. It's a pretty cool idea. Okay, our second idea, which we just got patented recently, is to use something different, which is to again measure the properties of our empty enclosure or room or whatever with this instrument. And then using the mathematical properties of the things that we measure here, we can figure out a way to send energy into this box such that 100% of it goes into the box and doesn't come out. So there's nothing reflected, there's nothing transmitted. All of it is absorbed inside the system. And that way we have a very efficient way of sending all the energy in. And that's our more recent patent that we just got, which is about using this thing called coherent perfect absorption for wireless power transfer. So that's another idea. But both of these, in some sense, can work together to make a more efficient way to make wireless power transfer.
Our second question is, what kind of possible rays could come off of a Tesla coil?
The other question you had was about what kind of rays come out of a Tesla coil. And yeah, Tesla coils are really cool, very interesting things. They use a thing called resonance, which is what we also use downstairs when we were doing that kind of time reversed stuff and the coherent perfect absorption. So resonance means that there's some kind of a mode of the system which can be excited and has very large amplitude oscillations of the electric and magnetic fields inside the enclosure. And you know, it's a really cool thing because it seems like you put a little bit of energy in, but somehow it seems to grow. It seems to get magnified by the resonator. And that's what Tesla used with his Tesla coil. He was basically building a resonator using wires and capacitors and things like that. And then he was able to take very low voltage and very high current and convert them into very high voltage and low current and create these kinds of sparks that came out into the air around the coil. And it's, you know, it's basically, it's kind of an extreme thing to do. It's cool, it's interesting, it's pretty dangerous too. You don't want to be near it. But, you know, basically the rays that you see are filaments of electricity. I mean, basically it's like lightning bolts that are coming out, but very small, but still very high voltage and very dangerous. So you really don't want to get near one of those things when they're operating. And what you see, of course, is light that comes from ionized air. I mean, the nitrogen and the oxygen have distinct colors that are produced when they get ionized, and then the electrons recombine with them. So it's a little bit like looking at an aurora in the sky, but it's like right nearby. It's really cool. So, and it also produces a lot of radio waves, a lot of interference. So it's a good way to kind of mess around and cause trouble with electromagnetic waves as well. So anyway, I think that's probably enough for now. I probably told you more than you need to know, but it's fun. This is what we do here in the lab. We just have fun with stuff, and you know, it's great. We can answer all kinds of questions, address all kinds of things that we're curious about, and that's what we do for a living here. So it's fun.
And our third and final question. How much space could the wireless energy provide for?
Okay, yeah, you had some other questions, Kincaid, and let me answer some of those. So one of the questions you had was how big of a space could be powered by wireless power transfer. That's a really good question, and we don't really know the answer kind of conclusively yet, but we think that something like the size of a room, like my office here, would be easily powered by this wireless power transfer technologies that we have. And the question is how big, you know, maybe a warehouse could be used to use a wireless power transfer system. It could be pretty big, something like that.